Okay, so after understanding the fundamental concepts of information theory applied to the discrete memoryless channel, we understood how to calculate the entropies like entropy at the transmitter end, h of x, the entropy at the receiver end, h of y, the joint entropy h of x comma y, which is the entropy of the system as a whole, entropy h of y given x, and entropy h of x given y. And after going through some of the examples how to calculate these entropies for a typical channel, now let us try to understand the one more term which is most useful term as far as the channel is concerned, a discrete memoryless channel is concerned, and that term is the term of mutual information. Now, what is mutual information? In simplest way, I can explain mutual information. So, the information which is exchanged mutually between the transmitter and the receiver, that is called as the mutual information. Like I have xi, which is the transmitted symbol, and I have yj, which is the received symbol. Then the information conveyed by a pair of symbol xj comma xi comma yj is nothing but the mutual information. How much information is exchanged mutually between the transmitter and receiver, that is called as the mutual information. Now in the simplest form, I can represent this mutual information by capital I. Capital I we earlier used for amount of information. Now with the same capital I that we are using for mutual information, but it was IK, that is the amount of information for the kth symbol, and here for the mutual information it is I of XI semicolon YJ. Now the difference in the notation you can look at here. Here it is a semicolon. Earlier case for joint probability we are simply using comma between the two variables xi and yj. So here I of small xi semicolon yj will be equal to log of p of xi given yj divided by p of xi. That is, it is the ratio of logarithmic of conditional probability xi given yj divided by p of xi. Now we know that xi given yj we can write down in terms of joint probability as p of xi comma yj upon p of yj. So by simplifying it, I got log of p of xi comma yj divided by p of xi into p of yj. Further, I know that the definition has given me I of xi semicolon yj as log of p of xi given yj upon p of xi. This probability determines the a priori knowledge of what was transmitted, because you have received something yj, but you are trying to predict what xi is being transmitted by the transmitter. So the ratio of these two probabilities determines the gain of the information, and that's why it is being recorded as mutual information. Now how to establish the formula for the mutual information? To establish the formula for the mutual information, we know now I of xi comma semicolon yj. Let us take the average value of this, which will give me I of capital X semicolon capital Y, which is summation over j summation over I p of xi comma yj into I of xi comma yj. Now I of xi comma yj we have already defined, that is log of p of xi given yj upon p of xi. If I substitute in this formula and if I expand this particular logarithmic ratio as minus, then I got p of xi comma yj multiplied by log of p of xi given yj minus log of p of xj. The division simply I try to represent in terms of subtraction. Then multiplying it here, p of xi comma yj multiplied by log of p of xi given yj minus p of xi comma yj log of p of xi. So that is going to give me the equation for mutual information, and this equation for the mutual information I can correlate in terms of entropy. So first I got this particular equation. Now, if I want to correlate this terminology in terms of entropy, then I know that h of x is summation p of xk log of p of xk. H of y is summation p of yj log of p of yj with minus sign. X given y has this formula, y given x has this formula. So if I represent this particular multiplication, xi yj into log of p of xi given yj is nothing but minus h of x given y, and this summation is h of x. From that I got the formula for mutual information as mutual information I of x semicolon y will be h of x minus h of x given y, or it is h of y minus h of y given x, or if I combine it, it will be h of x plus h of y minus h of x comma y. Please note down all these formulas which we require to solve the examples related to the mutual information, or rather the examples what we have solved earlier. In that example, the additional point we can calculate is the mutual information if we know the individual entropies of that particular channel. So I of x semicolon y will be h of x plus h of y minus h of x given y, or it is h of x minus h of x given y, or it is h of y minus h of y given x. So in the example, first the things will be asked to calculate all the entropies like that what we did in the previous example, and then based upon the entropy knowledge we can calculate the mutual information of that particular channel. So if I just want to conclude in short about mutual information, I can come back to this particular diagram. We have h of x at the transmitter end, h of y at the receiver end, h of x given y, h of y given x, and what is common in between them, that is a mutual information I of x comma y. How much amount of information is uh, mutually exchanged between transmitter and receiver, that is called as I of x semicolon y. So it's a reduction in the certainty of x due to the knowledge of y. So that is nothing but your mutual information. There are certain properties of the mutual information, that mutual information of the channel is symmetric, that is I of x semicolon y is exactly equal to I of y semicolon x. Please note down these properties. That first property is mutual information is symmetric, that is I of x semicolon y is equal to I of y semicolon x. The proof is very simple. I have to just correlate the equations of I of x semicolon y as h of x minus h of x given y, and if I find out the I of y semicolon x and represent them in terms of entropies, I may get the same equation by using Bayes rule. P of xj given yk upon P of xj is always equal to P of yk given xj upon P of yk, which will try to prove that both the mutual informations are exactly symmetric. Second property of the mutual information that we have derived in the equation, like I of x semicolon y is entropy h of y minus h of y given x. From the values of h of y and h of y given x, we can understand that the third property, mutual information is always greater than equal to 0. That means mutual information is always non-negative. We cannot say that negative amount of information is exchanged. That's why these are all positive terms greater than equal to 0. And final property, that I of x semicolon y will be h of x plus h of y minus h of x comma y. So these are the properties of the mutual information. Now this is just a sample example how to calculate the mutual information. A channel is represented by the matrix 3 by 4, 1 by 4, 0, 0, 1 by 2, 1 by 2. And I understand from this matrix is P of y given x. If I know P of x1 and P of x2 both are 0.5, we can calculate P of x comma y by multiplying P of x to the P of y given x, as we understood in the earlier example. Then once I know the P of x comma y, sum of its rows is P of x and sum of its column is P of Y
Sir,
from yes.
sir, आमचं lecture आहे.
But okay,
Business.
so we'll just conclude this example in 1 minute. So I can calculate P of yk, P of y given x, and from that I can calculate h of y given x, and from the equation I of x semicolon y, we can calculate h of y minus h of y given x. That is the way how we can calculate the mutual information.